let's gently explore some key concepts, creating a calm and clear understanding. Imagine we're gathering information about people's favorite restaurants. The restaurants they choose represent a specific type of data, a category, if you will. This is qualitative data, specifically nominal data, where the restaurants are simply names without inherent order. To summarize this data visually, think of a soothing pie chart, each slice representing a restaurant's popularity, or a calming bar chart, each bar showing how many people favor a particular place. Now, let's consider collecting information about patients' ages in the ER on a Friday night. Age is a quantitative measure, a ratio data type, where the values have a true 0 point. To represent this data, picture a smooth histogram, its gentle curves showing the distribution of ages, or a calming box plot, neatly summarizing the range and central tendency. Imagine a satisfaction survey where people respond on a scale from 1 to 5. This data, though numerical, represents ordered categories, making it qualitative ordinal data. We can visualize this with a comforting bar chart, each bar representing a satisfaction level, or a peaceful pie chart showing the proportion of people in each category. Let's consider a researcher tracking winter temperatures in Colorado. The daily temperature readings are quantitative data, specifically interval data, where differences are meaningful, but there isn't a true 0 point. Think of a smooth histogram displaying the temperature distribution, or a calming box plot summarizing the temperature range. What is the difference between a parameter and a statistic? Imagine a parameter as a characteristic of an entire population, while a statistic is a characteristic of a sample taken from that population. We use statistics to estimate parameters. Consider these symbols: X, mu, sigma, and S. Can you feel the difference? The symbols X and S represent statistics, describing sample characteristics, while mu and sigma represent parameters, describing population characteristics. Let's explore different sampling methods. A stratified random sample is like carefully dividing a population into groups, and then taking a random sample from each group. A cluster sample involves randomly selecting entire groups or clusters. A sample of convenience is gathered from readily available members of the population. A systematic sample selects every KTH element from an ordered population, and a simple random sample ensures every possible sample has an equal chance of being selected. Imagine histograms as gentle landscapes. A symmetric histogram is balanced, like a still lake. A skew-left histogram has a longer tail on the left, like a gentle slope downwards. A skew-right histogram has a longer tail on the right, like a gradual incline. If a data set is positively skewed, the mean is gently pulled towards the longer tail, making it larger than the median. If a data set is negatively skewed, the mean is gently pulled towards the longer tail, making it smaller than the median. If a data set is approximately symmetric, the mean and median gently align, reflecting the balance. Imagine a frequency distribution with the lowest class between 30 and 38. The midpoint, the gentle center, is 34. Now picture a frequency distribution with the highest class between 80 and 91. The midpoint, the gentle center, is 85.5. Consider a frequency histogram. To find the proportion of data at or above 28, gently count the frequencies in those classes and divide by the total. To find the proportion below 21, gently count the frequencies in those classes and divide by the total. Consider